Thank you. The goal of this presentation is mostly to get you guys to think about interesting places you may have data that you could use, interesting uses of it, and maybe some tooling and things like that. Unlike the ESNet presentation, which is about visualization, this is more about what sources of data can you get, and then what kind of analytics could you do. How many people export NetFlow, IPFIX, or sFlow to some set of tools today? Okay. How many people have or export data from some of the augmented flow formats like Cisco AVC or Citrix AppFlow from load balancers? Or I would say, how many people have telemetry from the network that actually give you information about network or application latency, loss, retransmits, or as Matt will talk about at the next presentation, throughput. Okay, so some of what I'm going to talk about is what's after NetFlow, or for those of you, again, IPFIX or NetFlow v9, how many people are using that? So the templates that you have in there, there's extensions that a lot of vendors support, and additional kinds of data that you can export. And some flow tools can even use that. So I'll breeze through a quick summary of NetFlow. Who here has used in production Cisco 7206 VXR? Anyone? Okay. For flow switching, which was an awesome concept until we had the first forward source address attacks and every packet was a flow. That was the problem with the flow controllers in the first version of SDN magic that everyone wanted to do. sFlow, there's religion all over this field. sFlow will tell you NetFlow is evil. NetFlow people will tell you sFlow is evil. sFlow is generally lighter weight, less parsing. It's just send some bytes from the header out. More real time, less work on the device, but it basically mostly works now. Flow's got some bytes and packet counters, some TCP flags, sometimes some other things, MPLS tag, MAC addresses, VLANs, but it's all aggregated around stuff that was going on a protocol to or from or both port and IP pairs. Most devices support a fixed sampling rate, but there's some interesting stuff that you can do with variable sampling to get more resolution. Most devices support only per packet sampling, which gives you some heart attack if you actually want to see data from an entire session. That's a Broadcom thing on a lot of switches that's actually getting upgraded. And while it seems like it's pretty simple, there's actually a lot that you can do. The good news is, so when's the last time anyone has anyone had a service impact in the last year from sFlow or NetFlow or IPFIX export? So it works pretty well. 10 years ago, that was not the case. And especially sFlow works pretty well. So the state of the actual tools is they all have suck. I'm hoping that there will be some tools that don't suck much or suck not at all and are on their way to greatness over the next decade. It's always been a big data problem. That and Usenet, and now Usenet's abandoned, so this is the fun thing for people to work on. The open source tools don't cluster, Silk, NFDump, PM account. A lot of people wind up doing their own. Some very interesting stuff you can do with streaming, Pipeline DB, and Druid, and some of the streaming databases. But then you can't look back into the past. It's just an awful lot of data. It doesn't sound like a lot, 4,000 flows per second, but that pretty quickly turns into billions in days and trillions overall. But with flow and some basic aggregation, you can do a whole bunch of interesting things. You can look at congestion. You can look at attacks. You can look at things that look like attacks but are actually misconfigurations of your load balancers, or people slamming you on your API. It's really the microscope of what's going on the infrastructure. Peering analytics, how many people use flow data for peering analytics? Who should I connect to? Or even, the advanced use of this and some of the data I'll show is maybe even who should I connect to for performance problems based on data rather than just people saying that, congestion or more coarse metrics. Planning and forecasting, modeling and planning, and how many people use flow to actually figure out packet miles and how much customers cost to deliver service to. So that's something that on the carrier side, even the enterprise side, right? If you can actually take BGP community and stick that in the flow and do some analysis, a lot of community systems actually talk about geo, and now you can compute at least a coarse packet mile, right? Or figure out which are my expensive links, which communities are over that. Let me look at who those top talkers are in that dimension. So it's slice and dice in different dimensions. So you can look at source AS, dest AS, look at traffic. You can do interface-to-interface pairs. You can say, if you keep it at enough resolution, you could just say, I want to look at what went from this interface to that interface and where it's going. It's all stuff you can do with the very basic flow. Market analysis, how many people find customers to steal from competing providers by looking at their flow data? No, I used to. So that's an interesting thing is, who am I peering with if I'm a provider? Who am I peering with? So I'm not getting paid to send that data. That's big customers behind that. If I get them directly on my network, now I get paid twice. And getting paid twice is a key to profitability for some providers, Comcast. So sorry. Again, with AS path, this tends to be one of the trickier things to do is merging BGP plus NetFlow, but doing it live can actually yield some interesting stuff. So, but what if we could get more, right? And what is more? I think of it as two dimensions. There's the semantics, which is URL, DNS query, DHCP request, things like that. There's application performance, which you can get on the host. You can get that on a sensor. You can watch the packets. You can make flow. I'll talk about some of the tools for that. Network performance, and there's more kinds of network performance than you could ever imagine that people have wonked about. I tend to like retransmits. I think we'll hear after this another metric. Some people like latency. Latency is much easier to draw and compute with, but it just also depends on your protocol, what matters. And you can get it often from passive observation, sometimes from the actual network gear that you've got installed. And it can be transmitted, that data, over IPFIX and v9, which were designed to have templates. Now, v9 is sort of sucky because there's these template IDs, but not per vendor, so people tend to stomp on each other sometimes, or sometimes even on purpose, whereas IPFIX is more designed to be generic for that. So some interesting things you can do with combinations of that. So where can you get data that talks about more than just the Gesinde, Gesalte, where did the bytes go? So there's a couple open source sensors. There's nprobe and Argus. Argus, the designer, as I said, there's lots of religion. He hates NetFlow with a passion because he feels it does not, as a protocol, IPFIX and v9, do not capture the richness of all the analytics that one could possibly do with this. And as a result, no one uses the tool because there's no backend that people can send to unless you do your own big data integration. But it's got really, really, really rich performance analytics, not so much on the semantics. nprobe straddles the middle. How many people use nprobe? I know one other person in the audience does because it's in the agent that we do. How many people use ntop? So ntop is a different code base and is top talkers mostly, but nprobe has a lot of decoders in it, and I'll show you some of that. And then there's boxes you can buy that are sensors that sit on physical taps or span. We tend to recommend people not do spanning because it can blow up your switches and networks or otherwise. So packet brokers, how many people, this is very enterprisey, use Exia, Gigamon, some of the packet brokers. So you'll find those very expensive boxes in the enterprise. They're designed to allow you to buy fewer, even more expensive boxes, which is why people buy them. So you can buy fewer $200,000 security appliances by buying $10,000 per port, 10 gig switches that basically copy traffic. But I would challenge you and say, how is an nginx log different than flow other than the format, right? It's got the semantics, it's got how many bytes, and sometimes, it might not have packets, but it's got bytes at least. It might not have TCP flags, but it's got the transaction time, and it's even can peek into the TCP info struct and get some network performance. Maybe that is flow. What about Bro? Bro logs have bytes and packets and some of the decodes. They're missing the performance, but why isn't that flow? Web servers, load balancers, in fact, exactly A10 has with sFlow some decodes coming out of their DDoS mitigation box. Sorry, Ron. And we'd love for Radware to do that too. And Citrix, NetScaler. Anyone use NetScalers? So NetScaler with Citrix AppFlow is IPFIX with some of this additional information that if you map, you can start looking at network versus application. How many people have heard, is it the network or the application is the problem in the last year? Right? So that's the goal, is how do we take data that we have and give people the tools for that? And the very interesting thing is that a lot of the people that we work with, that are trying to figure out this space, they actually really want everyone in the company to see the network data. It's just the network tools and the data's typically been locked and it's very networky. But generally, the problem is not, in fact, with the network. And so showing that actually helps everyone's sanity. So there's a lot of places that you can think of getting stuff. I'm going to talk through a few of them. How many people have Cisco ASRs? OK, I'm not recommending that you go home and type this in or use your magic config system or whatever. But has anyone heard of Cisco AVC? So the chipset can actually look at the packets and do some performance-based instrumentation. Round trip time, jitter, packet loss. And export that in IPFIX, and you can take that and put it into your flow tool if it can take that. I would say don't try to do this at 200 gigabits, but it's more than ISR level traffic that they have that instrumentation. Because there's NetFlow Lite and some other Cisco stuff that's designed to run on tiny, tiny switches and routers, but this is designed to run on the mid-scale. And it's NetFlow plus some data. AppFlow we talked about, that's HTTP request method, request size, request URL, TCP round trip time. So now we've got some network data and some application data. You put it together, you graph it. nprobe has, and again, I think the presentation will be online, but I can send it to you. It's got retransmitted packets, an application latency estimate, and client to server and server to client latency, which is it's respectively the latency and just the TCP session setup. And again, nginx and bro. Nginx has the semantics and can get performance, and bro can look a lot like flow plus some of the security decodes. So I think we think of these things as logs and either Splunk or Elkisize them, which is free-form search and more sysadminish, or Flowisize them, which is slice and dice in these different dimensions. And so I would just challenge to say there's some things that you typically think of as Splunky that actually could be flowy in terms of the dimensions and the slices that you want. Whether you take the data and aggregate it and throw it away, whether you have only streaming solution, whether you have the full retention, whatever your solution is. So how do you use this data? If you can get this data, and of all that stuff that I listed, is anyone taking that data today? I can tell you there's some fun stuff that you can do if you actually go get it. So how do you store and use it? So how many folks have ever had to go debug IPFIX templates in their tool to get something to map? So some of the flow tools will let you do that mapping. Or you just talk to your vendor and say, hey, I want to do this, or they have integrations. But your tool basically has to take it. If the thing you're using to take IPFIX doesn't want to store those templates, doesn't know how to query them, it's not going to help you. If you do big data, again, nprobe can emit JSON. Now you can elk it, or you can do whatever your tool is. So if you're building your own, easy. Otherwise, there are some tools that go do this. And so, I sort of think of what we really want is end user application, network performance, the host performance, the app internals like a New Relic or App Dynamics, the system metrics, really the 360. Right? Let us sleep unless a user is affected or a lot of users are affected. If they are affected, where's the problem? And I think we'll be able to get to that largely. I can tell you there's an open source system called Fastbit, which stores data in a columnar format. Luca at NTOP actually wrote a SQL. The library has a SQL-like thing, and Luca wrote a utility to actually query it, so you can actually run SQL-like queries over it. This is what we use to store stuff at scale, so you have an extensible schema. But there's plenty of tools that let you go in and do those mappings. So if you want more fields, you just say, oh, OK, that's the AppFlow field is this. Let me map that in. Someone's got to make a decision about the semantics. Like, is that RTT the same as that RTT? And ultimately, that's just something that, again, you can do or work with others on. And so what can you do with that? It's actually pretty interesting because performance data can be useful for security, and security, what you think of as security data, can be useful for performance. So really, I would say the semantics, as well as the performance, you put them together, and they can both use them both for a lot of interesting things. So the first is there a network performance problem? So if you just have, pick your favorite thing, throughput, retransmit, latency, jitter, retransmit is loss. Well, we already have flow tools that can aggregate that by AS or AS path or interface. Okay, well now I can see network latency by path. In Fastbit, it looks like something like this. You can query by retransmits that are more than a certain %. It's easier to work with if you play with this data, latency, because with retransmits, there's always a baseline retransmit. That's how TCP works. And you really need to normalize it to the number of packets, not even bytes. But it can be done. And then you can look at things like retransmit by the destination AS. Or you can look at something in the AS hop. Or client latency if you run nprobe and you can get that data. So that's sort of network by itself. How's it doing? Second thing is, well, OK, what's the network versus app? Where's the problem? And for that, you might want to look at the network latency and the application latency and do baselining or thresholds. And so now, again, you need a source of something that can do that estimate. And of all the sources that I talked about, some of them can do it, some of them can't. I would love if this was in every ASIC everywhere. And the new Broadcom has some interesting capabilities. Now, the problem getting this sort of data from the switches we all use, which are the Broadcom, white box or the Cisco or Juniper version, is the primitives are packet sample, not flow sample. Or you can't say for 1/10 of the flow hashes, give me all the headers or all the packets. And to do things like tracking latency, you need to see every packet in a flow or none of the packets in a flow. But the new Broadcom chips have that as a primitive. And there's even things that you can do, that you could program already and say, these are the flows that I want, give me all the headers for. You can already do that on a Cumulus or something like that. So if you can get that data, if you can get the network and the application latency, then you can start to visualize that and look at, so we say RTT over 2, so that's one-way trip time, again, from the TCP handshake. And you can look at it by port, protocol, however your flow tool uses it, maybe even what ports, what ASs, what next hop ASs, what countries, again, for debugging or alerting or however you want to look at it. But if you have URL, now you have to be careful, because a lot of flow tools, you don't want to store a 3,000 byte URL and refer a string and all the things that you have in HTTP. But if you do have that, well, you can find SQL injection attacks in some cases, like little Johnny drop tables, or Mr. and Mrs. Null as their path makes it its way across your network. And interesting things that you can do there. Another interesting thing, which is where performance and security come together, is e-commerce bot detection. There's Distill. There are a bunch of companies that help people. Basically, the other thing you can do is just shut off AWS, like null route AWS. That will also help with some of the bots. Someone was telling me about an end-user performance monitoring service whose agents are only on AWS, which is like, OK, you can tell how the robots are doing today. So that's very helpful. So again, I present this. I've seen people do some of each of these things with this kind of data, sometimes with commercial tools or services, sometimes in their own big data. If you're interested in the big data approach, and you actually want a free license for nprobe with the HTTP decoder, you can look at the Cisco OpenSock. I almost guarantee you'll get nowhere with it, because it's basically all the buzzwords of every big data thing mishmashed together. But it's an open source project that you can work with. And in there is an nprobe license with the HTTP decoder. And nprobe, without any of the decoders, can do retransmit and server, client, and app latency estimates. So some interesting things dimensionally to think about, some potential sources, and I'll put that back up. And some interesting things that you might want to do with it as you sit and think about your tools and analytics and That's it. I didn't think I would do that in under 30 minutes, but I went really fast. So, no. Oh, the sign. It says sign? Oh. Watch says 6 minutes, but what do I know? It's a semi-analog watch. Questions, comments, flames, or should we let Matt get in? Yes?
Quick question on the latency part. You're talking about using not synthetic.
Yes.
Just using actual.
Actual traffic.
Okay, and that's a function of the chipset of the devices that you would be taking this data from. Okay.
Or you can run the instrumentation on the server or the hypervisor. So you can run nprobe, or like for what we do, we run nprobe on a server. You have to be careful to not have the Heisenbugs, right? So you don't want to influence the performance, the production traffic by measuring it. But you can lock it to a core. You can do stuff like that, and run it on a server or hypervisor to get that also, or a sensor which is optically tapped or whatever.
Okay, and then outside of specific hardware agnostic, do you know of any other ways of capturing that TCP latency and the handshake?
Yeah, nginx logs. The nginx, are you a, feel free not to answer, I don't know how secret people are, but do you run content delivery? Like run web servers or just transport?
More of a hosting, but kind of the transport service. So what I'm trying to find out is some of the things that I looked at in the past was figure out how can we capture the latency between our clients, the web services, and our peering networks or transit networks, and figure out basically who to peer with based on latency and lowering that latency, but without having access to the actual web servers and not modifying the hardware with the chipsets of the routing devices in the middle.
Yeah, you're probably not going to find anything at scale as a hosting provider because you need to be able to deal with DDoS attacks and all that, and it's probably, but what you can do, and it's really cheap, we have some CDNs that I work with that do this, is you can get a Dell i3 box, $1,300 with an Intel chipset, use NTOP's PF ring and NTOP's nprobe, and it can do line rate 10 gig full duplex, IPFIX export, and you can even sample the flows, so you don't need to take, you can say only give me up to 4,000 flows per second, but sample it with a the sample rate. And in that, just in their standard templates are the ACK to SYNAC, the SYNAC to ACK of SYNAC latency, and an estimate of the time to first byte in response. So you get source, inbound source retransmit and dest retransmit. So right there you've got 6 metrics, and you can pick your favorite. I like retransmits, but other people like different things. And how many people use NetOptics taps, the $1,000 10 gig taps? They're great, awesome. You don't need Gigamon. So you can get a 70-30 light splitting tap or a 90-10 and divert some of the light to a $1,300 server using software. He's sort of source available on some stuff, but for another, basically you're talking about a $2,000 or $3,000 box, a $1,000 tap, and now the question is, do you tap it from your switches? Do you tap it at the external side? Because you probably have lots of, but you can get that data passively, just not from the routers and switches today, unfortunately. I would love for that to be the case, but I haven't found one. Arista can't do it, Cumulus can't do it, Pluribus can't do it, none of those guys can do it.
And sorry, just last question. You mentioned on the ASR boxes, there's something that actually measures the TCP latency?
Yeah.
It was that?
Yeah, it's called Cisco AVC. And there's round trip time, packet loss counter, which I think is actually transport. So I think that's TCP. And so I think there's some data in there. And you can summon your Cisco rep to Mastros and have them buy you dinner and talk about that stuff. Are we out of time?
Thank you.
Oh, okay. Yeah? Okay. Yeah, good luck with it. Instrument away. Any other questions? Matt, I should leave the VGA, the ancient tech, the CGA adapter here.